Okay, hello again. This is the chapter on chemical formula and equations. So we're going to learn how to write chemical formulas and how to balance chemical equations. So first of all, the molecular formula is a formula showing the total number of atoms in the molecule. So if I have something like this, I want the total number of iron, total number of carbons, total number of oxygens. That is the molecular formula of this compound. If I have something like this, lactic acid, so I count all the carbons, all the hydrogens, all the oxygens. That is the molecular formula of the compound. Same for this one. This one has how many sulfur, how many fluorine, how many oxygen. That makes up the molecular formula. Okay, so which formula represents caffeine? So we count all the number of carbons, number of nitrogens, number of hydrogens. Can you count them all? Your answer is C8H10N4O2, right? Okay, the formula of the main compound used as a source of sodium sulfate is sodium sulfate 10 water. How many different elements are shown in this formula? Remember that sometimes we have water of crystallization, and water of crystallization, the 10 water that's written at the end of sodium sulfate, is actually part of the molecule. So how many total different number of elements? I have sodium, sulfur, oxygen, hydrogen. That means I have 4 different types of elements. Now the molecular formula in most cases has to be determined from the name of the compound. So if he gives me the name and tells me to write a chemical formula, then the first thing I should do is write the symbols of each element. Now put the valency of one under the other. And the question now is, what do we mean by valency? Now, valency is basically the number of electrons lost or gained in order to have a full outer shell. For example, anything in group 1 has 1 electron in its outer shell. It needs to lose that 1 electron, so we say its valency is 1. Anything in group 2 has 2 electrons in its outer shell. It needs to lose these 2 electrons, so we say that the valency is 2. Anything in group 3 has 3 electrons in the outermost shell. It needs to lose them, so its valency is 3. Anything in group 4 needs 4 electrons in order to have a full outer shell, so its valency is 4. Anything in group 5, now in group 5 we have a choice. We either lose 5 electrons or we gain 3 electrons, and in that case it is easier to gain 3, so we say that anything in group 5 has a valency of 3. Anything in group 6 needs to gain 2 in order to have a full outer shell. I'm just reminding you that a full outer shell means a total of 8. So that means that anything in group 6 will have a valency of 2. Anything in group 7 has a valency of 1. What about group 8? We said group 8 or group 0 already has a full outer shell, so it does not need to gain or lose any electrons. So actually its valency is 0, and it will not make any compound with any other element. Okay, there are some things that we will be talking about that is not in the periodic table. So these things you have to memorize. So if we say something hydroxide, you should remember that hydroxide is OH, and it is written OH, not HO. OH with a valency of 1. Nitrate, you should write NO3, valency 1. Nitrite with a T is NO2 with a valency of 1. Ammonium is NH4 with a valency of 1. Remember that there's something else called ammonia. Ammonia is NH3. Ammonium is NH4. Carbonate is CO3 with a valency of 2. Sulfate is SO4 with a valency of 2. Phosphate is PO4 with a valency of 3. You have to memorize this. So remember that phosphate is the only one that has a valency of 3. Carbonate and sulfate have valencies of 2, and the rest have a valency of 1. Okay? Now, remember that the valency of transition metals, we haven't talked about transition metals, they have to be indicated, because if you remember, we said transition metals may have more than one valency. So actually, if I say iron, I have to tell you whether it's iron 2 or iron 3 in order to be able to write the formula. copper 2, sometimes it's, in most cases in our syllabus we use copper 2, silver 1. The valency of zinc is always 2. No one is going to tell you valency of zinc. You have to know that valency of zinc is 2. Okay, so what is the formula of the compound formed between magnesium and fluorine? Remember that we said, how do we write the formula? You write the symbols of each one. So you're going to put symbol of magnesium and symbol of fluorine, and then you put the valency of one under the other. So magnesium, you look in the periodic table, it's in group what? In group 2. That means its valency is 2. I put the 2 under the fluorine. Now fluorine is in group 7. Group 7 means it has 7 electrons in its outer shell. That means it needs 1. So anything in group 7 has a valency of 1. Now the 1 is understood. We don't write 1 under anything. So actually, if we're looking at the periodic table, the magnesium valency 2, you put the 2 under the fluorine. The fluorine is in group 7, valency 1. You don't put anything under the magnesium, and that means that the correct formula is MgF2. Okay, what is the formula of magnesium nitride? Now I'm going to remind you again. Anything with a D is from the periodic table. So in the periodic table it's called nitrogen, but if it is a compound with something else, it is something nitride. Just like oxygen, but something oxide. Chlorine, but something chloride. So the things with a D are what you have in the periodic table. So this is nitride, not nitrate, not nitrite. Okay? Nitride is just nitrogen. Now again, magnesium nitride means magnesium Mg and nitrogen is N. The valency of magnesium under the other one. So valency of magnesium is what? 2. I put the 2 under the nitrogen. The valency of nitrogen, I look at the periodic table, nitrogen is in group 3. So if it is in, nitrogen is in group 5, so it has a valency of 3. That means I put the 3 under the magnesium. So my correct formula is Mg3N2. Okay. Okay, phosphate ion has a formula PO4 3-. Deduce the formula of the rubidium phosphate. Remember that on its own it could have minuses, but if you put it with a compound you don't put the minuses. So rubidium is Rb and it is in group 1. Phosphate is PO4. You don't put the 3-. This just tells you that its valency is 3. So if you have a certain charge, the charge is the same as the valency. If he gives you something that you've never seen before, the charge on the ion is the same as its valency. So phosphate has a valency of 3. I put the 3 under the rubidium. Now rubidium is something in group what? In group 1. So I don't put anything under the PO4. Okay. Correct name of the compound with the formula copper sulfate. So copper is Cu and sulfate is SO4. Valency of copper is what? If he says that I have copper sulfate CuSO4, that means that the valency of the copper is the same as the valency of the sulfate. The valency of sulfate is 2, and that means that when you have 2 here and 2 here, you cancel them. And that means that you have CuSO4. So CuSO4 must be copper 2 sulfate, not copper 1. Do we understand this? If they have the same valencies, the valencies cancel. If you're supposed to write a valency under the sulfate has to be between brackets. And sulfate is always SO4. You never cancel the 4 with anything else. Got that? Okay. Let's try again. Lithium oxide. What would be the formula of lithium oxide? He's telling me that lithium is +1. That means lithium has a valency of 1. And the oxide ion, which is the oxygen, has 2 negative charges. That means the oxygen has a valency of 2. So when I write the formula, we said write the symbol of each one, the valency of one under the other. So lithium is valency 1. 1 is not written, 1 is understood, so I don't write anything under the oxygen. But the oxygen has a valency of 2, so I have to put the valency of 2 under the lithium. Okay? Lithium carbonate. If I'm writing carbonate alone, remember that the carbonate alone will have 2 minuses. But when I put it in the formula, the 2 minus is cancelled, okay? And we said 2 minus because the valency is 2. Okay, in which row is the formula not correct? So let's take a look at this. How do I write aluminium sulfate? Aluminium is Al, sulfate is SO4. Then valency of aluminium, I look at the periodic table and the valency of aluminium is 3, so I put the 3 under the sulfate. The valency of sulfate is 2, so I put the 2 under the aluminium. So that is correct. Calcium nitrate, that is correct. Potassium sulfide, that is correct. But C has iron 3 bromide. When I say iron 3 bromide, that means that the valency of the iron is 3, and we said the valency of one goes under the other one. So I'm supposed to put the 3 under the Br, not the iron. Okay? Give the formula of the 2 ions in lithium fluoride. So lithium fluoride is made up of the lithium ion and the fluoride ion. The lithium ion has lost 1 electron, so that's +1. The fluorine is a halogen, group 7. It gained 1 electron, so it's 1 negative. Okay, let's try these. He wants me to write copper 2 plus with Cl minus. So that means I put the Cu and the Cl. Copper 2 plus means that the valency of the copper is 2, so I put the 2 under the chlorine. Valency of chlorine is 1, that means I don't put anything because it's understood. Okay? Now I want ammonium sulfate, so I put the valencies of the symbols of each one, and then the valency of ammonium is 1. Even if you don't remember, he puts 1 positive there. So, and you should know that its valency is 1, so you don't put anything under the sulfate. But the valency of sulfate is 2, so you have to put 2 under the NH4. And we said if we need to put any numbers under the groups, hydroxide, nitrate, nitrite, ammonium, carbonate, sulfate, and things like that, we need a bracket around them. Okay, so this is the formula of ammonium sulfate. Okay, let's try writing the formula of iron 3 carbonate. So I have iron 3 plus and I have carbonate. So I put the symbols of each one. If iron has a valency of 3, I put the 3 under which one? Under the carbonate. And the carbonate has a valency of 2, so I put it under the 2. And remember, you don't put any positives or negatives anymore once you write the formula. Okay? Another thing that you need to remember, how do you write the formula of acids? Now, any acid will start with H. So, hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, they all start with H. Now, you need to know which one is hydrochloric. It is the acid that has chlorine. So I have the H with a Cl. Each of them has a valency of 1, so I don't write anything under each of them. Now you need to remember that nitric acid is the acid that has nitrate. Nitrate is what? Nitrate is NO3 with a valency of 1. So you don't put any numbers under the hydrogen. Now sulfuric acid is the acid that has sulfate. Sulfate is SO4, valency 2, so I need to put the 2 under the hydrogen. Phosphoric acid is the acid that has phosphate. Phosphate has a valency of 3, so I put it under the hydrogen. Carbonic acid is the acid that has carbonate, and that has a valency of 2. Okay, now there is in some cases the name indicates the number of atoms, and this is usually between 2 nonmetals. So if I have 2 nonmetals, I could say something monoxide, something dioxide, something trioxide. If the name says monoxide, I just put 1 oxygen. Dioxide, I put O2. Trioxide, I put O3. And forget about the valencies. Don't say what is the valency of this and I put it under the other one, and what's the valency of this and put. We don't do that if he already specifies whether it's mono or di or tri. Do we understand that? Okay. So for example, if I want to write the formula of sodium oxide. Sodium oxide means sodium and oxygen. The valency of sodium is 1, so I don't write any numbers under the oxygen. The valency of oxygen is 2, so you put a 2 under the sodium. Magnesium chloride, MgCl. The valency of magnesium is 2. I put it under the Cl. Ammonium chloride, and so on. Okay, so let's try this. Write the chemical formula for the following compounds. Could you try doing this and then check if your answers are correct or wrong? How do we write sodium hydroxide? Sodium is Na. Hydroxide is OH. What is the valency of each of them? 1 and 1. So sodium hydroxide is just NaOH. Potassium iodide. Potassium from the periodic table is K. Iodide is I. So, and each of them has a valency of 1. Please don't forget to check the valencies. So you write the symbols and check the valencies. You put the valency of 1 under the other. Lithium carbonate. Again, I'm going to write the symbols and the valency of 1 under the other. Valency of carbonate is 2, so I put it under the lithium. Valency of lithium is 1. I don't put anything under the carbonate. Sulfuric acid. Remember we said acid starts with H, and sulfuric acid is the acid that has sulfate. Valency of sulfate 2, so it has to be H2SO4. Now when we say copper 2 chloride, again I write the symbols, and copper 2 means the valency of copper is 2, so I put the 2 under chlorine. Aluminium sulfate, I write the symbols and the valency of 1 under the other. The valency of aluminium is 3, the valency of sulfate is 2. Iron 3 oxide, let's try that. Iron is Fe, oxygen is O. Oxide is the same as oxygen. Chloride is the same as chlorine. So, the valency of iron is 3, so I put the 3 under the oxygen. And the valency of oxygen is 2, so I put it under the iron. Calcium sulfate. Now, calcium and sulfate both have a valency of 2. And that means they cancel, so I don't put 2 here or 2 here. This is just CaSO4. Zinc phosphate. The valency of zinc was what? Valency of zinc is 2, phosphate is 3. So I put the 2 under the phosphate and the 3 under the zinc. Remember the valency of 1 under the other. Okay, how do we write balanced chemical equations? To write a balanced chemical equation, we write all the chemical formula of the reactants and the products. Remember that the word reactants means whatever is before the arrow. Products are whatever is after the arrow. Now, we balance the equation, and that means that I look on both sides of the arrow and I make it so that I have same number of atoms. And that is by increasing whatever is less, and I'll show you how. If you're required to write the state symbol or the state of each reagent, you should remember that if something is a solid, you write S. If something is a gas, you write G. If something is a liquid, you write L. If something is aqueous, dissolved in water, you write AQ. Okay, you should also know that some molecules are diatomic. Diatomic means if they stand on their own, they should be in twos. So a molecule is made up of 2 atoms. For which one? Hydrogen, nitrogen. So if the equation says plus hydrogen, plus nitrogen, plus oxygen, plus fluorine, plus chlorine, plus bromine, you write them with a 2 below them. But if they are a compound with something else, then what goes under them should be the valency of the other element. So don't put 2 if it's a compound with something else, unless if the other one has a valency of 2. Okay, let's try balancing simple equations. So we look on both sides of the arrow. How many zinc atoms do I have before the arrow? I have 1. How many zinc atoms do I have after the arrow? I have 1. Remember that when I have ZnCl2, that means I have 1 zinc and 2 Cls. Now, if I have 2 Cls after the arrow, then I also need 2 Cls before the arrow, and we do that by putting the number before it. Don't put a number under it. So don't say HCl2. No, it is 2 before the HCl. And when you put 2 before the HCl, this applies to both hydrogen and chlorine. So that means I have 2 hydrogens and 2 chlorines. And that balances the equation on the other side. Okay, let's try this one. Magnesium plus HCl to give magnesium chloride plus hydrogen. Again, how many magnesium before the arrow? 1. How many magnesium after the arrow? 1. How many hydrogens before the arrow? 1. How many hydrogens after the arrow? I have 2. So I need to make that other one 2 also. We increase the one that is less. So I put it 2 before that, so that now I have 2 hydrogens and 2 chlorines, which would balance the equation. Okay, let's do this one. I have SiO2 plus carbon to give Si plus CO. Now, how many Si before the arrow? 1. After the arrow? 1. How many oxygens before the arrow? 2. So I need 2 after the arrow. I have only 1, so I put 2 before the CO. But that now ruins the number of carbons, because now I have 2 carbons, so I need 2 carbons. Do you understand the idea? Count on both sides of the arrow and increase the one that is less. Okay, now Fe plus HCl, this is a metal plus acid. A metal plus acid will give something plus hydrogen gas. Now, balance the equation. Also, we have 2 hydrogens and 2 chlorines after the arrow, so I need 2 hydrogens and 2 chlorines before the arrow. Okay, let's try balancing this. Now, he's saying complete the chemical equation for the reaction of aqueous bromine with aqueous potassium iodide. So he already tells me that I should start with bromine. Now, how do I write bromine? You should realize that bromine is diatomic, so you write it Br2. It's one of the things that is diatomic. Do you remember which ones were diatomic? H, N, O, F, and everything under the F. Now I have 2 bromines before the arrow, so I need 2 bromines after the arrow, and that balances the equation because I also have 2 potassium and 2 potassium. Okay, copper. Okay, oxygen is removed from air by passing it over heated copper. So that means that I'm reacting copper with what? With oxygen. How do I write the oxygen? Oxygen is diatomic, so I have to write it O2. Now, how many copper? As I have that, how many copper before the arrow? I have 2 coppers before the arrow. So I need 2 coppers after the arrow, because that will also give me 2 oxygens after the arrow to balance what I just wrote. Potassium reacts with bromine at room temperature to form potassium bromide. Write a chemical equation and include state symbols. Okay, potassium plus bromine. Bromine is diatomic, so it has to be Br2. To give potassium bromide, potassium is valency 1, bromine valency 1, so that's how I write it. Okay, balance. How many potassiums before the arrow? 1. After the arrow? 1. How many bromine before the arrow? 2, so I need 2 bromines, so I put a 2 before the KBr. Now that means that now I have how many potassium after the arrow? 2, then I need a 2 there. Okay, what about state symbols? We said potassium is a metal. Metals are solid, so that should be an S. Bromine, you should know, is liquid, and KBr is a solid. Okay, complete the chemical equation for this reaction. Okay, so this is just balancing. Before the arrow I have how many S? I have 1 sulfur and another sulfur in the H2SO4, right? So I have actually 2 sulfurs before the arrow. So I need to put 2, okay, I need to put 2 before the sulfuric acid in order to balance the hydrogens, because you have hydrogens. When you have 2 H2O, that means you have 4 hydrogens and 2 oxygens after the arrow. And that means you need to put 2 before the sulfuric acid in order to have 4 hydrogens. Now, how many sulfurs do I now have? I have 2 and the first one, which is 3, so I need to put 3 in front of the SO2. Now let's count the oxygens. Are the oxygens balanced or not? How many oxygens do I have before the arrow? Before the arrow I have 2 times 4. Can you see that? 2 times 4 is 8 oxygens before the arrow. Now after the arrow I have 2 in the water, 2 H2O, that means I have 2 oxygens, and 2 times 3, which is 6 oxygens in the SO2, so 6 plus 2 is 8, and that is balanced. Do you understand how to count the number of oxygens? You multiply the numbers. Okay, sulfur dioxide is produced on a large scale by heating iron pyrite strongly in air. The iron pyrite reacts with oxygen in the air, producing iron 3 oxide and sulfur dioxide. So he says that the iron pyrite is FeS2. So I'm writing FeS2 with oxygen to form Fe2O3 plus SO2. Can you sit down and try and balance this? Take a minute to balance and check. You will need 4 iron on both sides, you will need 8 sulfurs, and you will need 2 times 11 of oxygens. Are you able to get that? Let's try writing the balanced equations for these reactions. So he's saying nitric acid. How do I write nitric acid? Nitric acid is HNO3 plus calcium hydroxide. How do I write it? Calcium hydroxide, calcium nitrate. Will you be able to do something like this? Try the next one. Take a minute and try the next one. This should be your balanced equation. Okay? Try these. Stop the video and try these on your own. Okay. We can also write ionic equations. And an ionic equation, or to write ionic equations, we write the balanced chemical equation, just as we just did. Determine the state of each substance. Substances that dissolve in water are things that include any sodium compounds, potassium compound, ammonium compound, all acids, all nitrates, barium chloride, copper sulfate. You need to remember that these things are soluble in water, and that means that their state in the equation would be AQ, or aqueous. So anything that is ionic, dissolves in water, separates all the ions and write the charges on each. Do not ionize anything that does not dissolve in water. So you don't ionize anything that's a solid or a liquid or a gas. And whatever comes out, you cancel the ions that are exactly the same on both sides of the arrow. Let's try this. So we're supposed to write ionic equation for this reaction. So we write a normal equation for balanced equation for all of it. Silver nitrate plus sodium chloride to give silver chloride plus sodium nitrate. And you should realize that silver nitrate is aqueous because it is a nitrate, and we said all nitrates are soluble. Sodium something is soluble, so sodium chloride is aqueous. Sodium nitrate after the arrow is aqueous. But the only one that is a solid here is silver chloride. Remember, anything that's a solid or liquid or gas, you leave it as it is. You don't do anything to it. The others, you have to ionize. Ionize means you're going to break it up into positive and negative ions. The first one is positive, the second one is negative. The first one is positive, the second one is negative. The only one that I don't do anything to is the AgCl. And then I cancel whatever is exactly the same on both sides of the arrow. So Na plus and Na plus. NO3 minus and NO3 minus. These are cancelled. What am I left with? I'm left with the Ag plus Cl minus to give AgCl solid. Now in some cases, he will not give you any equation, and he will just tell you, write an ionic equation for the formation of AgCl. Well, you should know that if I have AgCl and I'm trying to form it, which ions am I going to need in order to form silver chloride? Well, I'm going to need silver ions and chloride ions. So you can actually write the last equation without going through the steps before if he did not give you any specific reaction. Okay, let's try this. Iron plus copper 2 sulfate to give copper plus iron 2 sulfate. So let's write the basic equation. Iron, copper 2 sulfate. We said the copper is valency 2, sulfate valency 2, so you don't put 2 under any of them. To give copper plus iron sulfate. Now, which one is a solid? The metals are all solid. So iron is a solid, copper is a solid. But the copper 2 plus is not the same as copper. And Fe2 plus is not the same as Fe. So they don't cancel. The only thing that's exactly the same on both sides is the SO4 2 minus, and that cancels, so you end up with Fe plus Cu2 plus to give Cu plus Fe2 plus. Okay, take a minute to do this and then check the answer. So I have barium chloride plus sulfuric acid to give barium sulfate plus hydrochloric acid. How do we write it? This is how we write the normal equation. You need to balance. Then you ionize everything. So I have barium. Barium is valency 2, so it has 2 plus on it. Now the Cl, I have 2 of them, but each of them has 1 negative. H2SO4, I have 2 hydrogens. Each of them is a positive. And I have SO4 with 2 minus on it. Remember that the number of the charges is the same as the number of the valency. Barium sulfate is a solid, so I don't do anything to it. Now, 2H plus and 2Cl minus from the 2HCl. You cancel whatever is exactly the same on both sides of the arrow. So 2Cl minus and 2H plus are exactly the same. They're cancelled. And you end up with barium 2 plus SO4 2 minus to give barium sulfate. Again, he can just ask you to write the ionic equation for formation of barium sulfate. Well, barium sulfate will be formed from barium ions and sulfate ions, and the charges are the same as the valencies. Okay, some ionic equations involve electrons. So in some cases, I have, for example, H plus. What should I add to the H plus to change it into H2? Well, I add electrons. To balance positives, I put negatives. So to balance a positive, I put electrons. And I need to balance the hydrogens and balance the charges. So I have 2 hydrogen, 2 hydrogen. But if I put 2 in front of the H plus, that means I have 2 positives. That means I have to balance it with 2 negatives. Ag plus to give Ag. Again, the plus gains electron. How many electrons? Only 1, because this will balance the 1 positive on the Ag. Zinc 2 plus what? Plus 2 electrons, because I want to balance the 2 positives. Copper 2 plus what? Plus 2 electrons to balance the 2 positives. Negative ions and metals lose electrons. So if I'm starting with something that has a negative charge, OH minus, it will lose electrons. And if you sit down and balance it, you will find that you will need to do this kind of balance. Cl minus will lose electrons, but then I need to balance the Cl atoms and I need to balance the charges. So if I have 2 Cl's after the arrow, I need 2 Cl's before the arrow. That means that now I have 2 electrons before the arrow. I need 2 negatives before the arrow. I need 2 electrons after the arrow. Okay. Iron will lose electrons and become iron 2 plus. So if it becomes iron 2 plus, that means it needs to be balanced with 2 electrons. If I don't have a net charge before the arrow, I should have a 0 net charge on the after the arrow. Na will lose 1 electron because it's going to form only 1 positive. Okay, so this is the end of this chapter. Please go back and study what we just said. Try the questions and check the answers in the next video. Thank you.